Welcome back, folks, to Scripting for Linguists. In this episode, I'd like to answer this question. How much faster is it to use parallel processing when calculating frequencies of words in many small files? In a previous video linked to above, I looked at 4 different algorithms for calculating frequencies in many small files, and discovered that of the 4 algorithms that I use, they're all pretty close to each other as far as time of execution, but that the get method was slightly quicker. The get method on dictionaries in Python is slightly quicker. So my next question is, well, how much faster can parallel processing be? I'm going to use the Spotify Podcast Dataset, well, about a quarter of it. The dataset itself has over 1 billion words of transcribed speech, and I am going to use about a quarter of it. I'm going to use about 230 million words of this data set just to make this demo reasonable amount of time for execution. So the first approach we're going to take is the sequential. We're going to sequentially just go through each of the almost 40,000 files, and we're going to populate one dictionary with all the words across all the files. This is what I did in the previous video. Okay, and so we're just going to redo this to get some times. I'm going to print out some information about the dictionary that comes out, just to make sure that the data that we get, or the numbers that we get with this run, with this approach, are the same numbers we get with the parallel processing approach here in a couple minutes. Okay, so let's just go ahead and run this. Ready, set, go. All right, so it's finished there after 10 iterations, 10 trials. And I have these numbers printed out just to double check that we get the same results with our next approach. We have 242,527 word types, that is distinct words. We have almost 230 million word tokens. The word the occurs almost 7.9 million times. Tree, 12,651. Backpack occurs 1,520 times. Good. I'll just keep note of those. And then here are the times of the 10 trials. And we have a median. We have a mean of 51.6 seconds and a median of 49.9. We'll round up to 50, I guess. So let's record those real quick. If we go back over to here, and that was 51.6, was it? Jump back here. 51.6, yeah, we'll round up. 51.6 there, and we'll say 50.0 there to round up. Go over here and go 50.0. Okay, so that's for our sequential run. That's the times for our sequential run. Now let's go talk about parallel processing. So the approach here is a little bit different. We're going to kind of a 3-step approach. The first step is to get all the text file names, the actual file names, the pathway all the way down to the text files first. And so we have a list of almost 40,000 text files. Excuse me, the pathway to the text files in one list in Python. And then we're going to define a function here from line 16 to 23 in which we give the function one pathway to one text file, and it returns a frequency dictionary of the words in just that one text file. Okay, so it's just working on one text file at a time. And then here, we're going to do the parallel processing. Let me jump to the top of the script. So the multiprocessing module in Python has a pool object, and that pool object has a map method. And so I'm going to say, hey, I want you to use 8 processes. Now, why 8 processes? Well, because on this MacBook Pro 2021 MacBook Pro, if I look at how many cores this thing has, if I go to the Apple, look here, go to System Report, it says here I have a total number of cores is 8. It's kind of small, but that's what it says up there, right there. 4 performance and 4 efficiency right there. So I have 8 cores right there. So that's why I'm specifying 8 back over here to the pool object. And I'm going to apply this function that works on one pathway at a time to the list that has all the pathways. Okay, so it's going to apply this function to each element of this list, which is a pathway to one file, or to the 40,000 files total, but it's going to work on one at a time. And it's going to have 8 workers or 8 processes there. And then so the result, what it returns, the return value is a list of dictionaries. It's a list of almost 40,000 dictionaries, and each dictionary has the frequencies of words in one file for the file that the pathway was pointing to. And then the third step is to flatten or to merge all of those small dictionaries into one large dictionary. Again, with the idea that we're trying to reproduce what happens with the sequential algorithm. Okay, and so we will do that. Here we go. Ready, set, go. Okay, it is finished now. First thing we want to do is double check we're getting the exact same numbers. 242,527 word types, that is unique words. Yep, that's right. Almost 230 million word tokens. Yeah. Almost 7.9 million thus. 1,520 backpack. Yeah, so looks like we're getting the exact same frequencies, exact same numbers. Here are the times of the 10 trials. And here is the mean and the median. So we have 22.9 and 21.0. So let's jump over to here. I just already forgot. 21.9 was it? 22.0 was it? Let me see what those were. Yeah, 22.9 and 21.0. Let's just double check. Now it's 22.9. So, what is the take-home message? Wow. Okay, yeah, so it's a lot quicker. In fact, if we want to do a little bit of math here, if we take B2 divided by B3, we get about 2.25 times quicker. It takes about 2.25 times longer, that is, to do the sequential approach than the parallel approach, getting the same frequency numbers. So to answer our question, how much faster is it to use parallel processing when calculating frequencies of words in many small files? It is over 2 times quicker, 2.25 times quicker to do parallel processing to get frequencies of numbers in Python. Great, so that brings us to an end. I will leave a link to these two Python files that I use in this video in the description of this video. See you next time.